Today we're doing section 9.4, and today's lesson is going to be about the trigonometric ratio, the tangent ratio. And so this is going to be our first trig ratio. And I really want to make sure we really get a firm basis of what the trigonometric ratios are, because if you continue on in math, at least through our high school system, you will take pre-calc trig after algebra 2. And trigonometry is, the trig part of that. So it's vital that you know these functions now. So a trigonometric ratio is a ratio of the lengths of two sides in a right triangle. So simply put, if we draw a right triangle here, make that a right triangle, we can label this guy JLK. We'll signify that angle L is our right angle there with our indicator, and let's look at angle J there. Right? So, oops, sorry. And then we'll go ahead and draw another right triangle. This one will be similar. So we got triangle X, Y, and Z. Z will be our right angle on this one. And since these two triangles are similar, we're going to say angle J is congruent to angle X. So triangle JKL is similar to triangle X, Y, Z. And so if we look at these functions here, all right, let's look at the leg KL. So look at K to L. Oops, I meant to do that in a Sharpie color, so we'll redraw that there. Let's look at the leg KL. All right, what leg corresponds to KL? Well, that's going to be YZ. So if we take the ratio of KL over YZ, we know that it's going to be equal to a ratio of two other sides. So let's look at JL over ZX. All right. This was established in the similarity rules that we did last chapter, where the ratio between similar side lengths are the same across similar triangles. And these are actually trigonometric ratios. And so the cool thing about trig ratios is that trig ratios are constant given the same angle measurement. So if I were to draw another triangle in this group of right triangles, say that one right there, and we call this triangle ABC. Oops. And we're going to say that C is our right angle and A is congruent to J and X, then this leg that's opposing right there, oops, forgot to change the highlighter again. This leg that's opposing right here, and this leg that is adjacent right here to angle A, it's going to be the same ratio. So I really think that's a cool fact to know about trigonometric functions. And so, oops, I'm hearing a weird noise in my house. Oh, it's a washing machine. Okay. So the tangent ratio is the ratio that we have just described right here with this blue leg and this green leg. The tangent ratio is a trigonometric ratio for acute angles which involve the legs of the right triangle. And so I think it's really important that all of these triangles that we just drew, triangle ABC, triangle JKL, and triangle XYZ, notice that all of our ratios, all the blue segments, those are all legs. All the green segments, those are all legs. We didn't highlight the hypotenuse at all. The tangent ratio has nothing to do with the hypotenuse. And so now a more formal definition of the tangent ratio is going to be the following. Give this a big ol' title here, and we're going to call this the tangent ratio definition. All right. Let triangle ABC be a right triangle with angle A. Or more specifically, with acute angle A. All right, so the tangent of angle A, written as the tangent of A, and now you'll see some people put the angle in parentheses. Our book does not. I prefer to put the angle in parentheses. It makes it cleaner. Is defined as the following. The tangent of A is equal to the length of the leg opposite angle A divided by the length of the leg adjacent to angle A. And so if we were to draw this triangle, I'm going to color code this triangle now that we're finally drawing it. So there's going to be one leg, here's going to be our other leg, and then oops, is that a right angle? Yes, it is. And then we're going to connect the green leg and the red leg or blue leg with this red hypotenuse. We can label this triangle ABC. And this whole time, this definition has been focused on angle A right there. And now let's look at angle A's point of view and identify the leg opposite of angle A. Well, that's going to be the leg that angle A is not touching. So this is going to be our opposite leg. So in this trig function, the tangent of angle A on top is going to be the length of BC. And now let's look at the leg that is adjacent to A. Well, there's two segments that are adjacent to A, right? It's both of those, that red segment and that blue segment. But the key here is that it's the leg. And the leg is going to be our shorter distance because our angle, our longest side is our hypotenuse. So this is going to be the adjacent leg right here. And so that's going to be BC over AC. So our tangent function is just a ratio. And then, of course, this red leg is our hypotenuse.
Mic off. Mic on.
Sorry, that was me muting myself to cough. So I'm going to leave this tangent ratio right there, right? Because the first part of it was just a bunch of hoopla. And we're going to go ahead and find the tangent of a couple of angles now. So in this example, we're going to want to find the tangent of angle R and the tangent of angle S. And we're going to round these to 4 decimal places. I don't like that line there. There we go, got our right triangle. This is going to be triangle R, S, and T. So T is going to have to be our right angle. And we're going to give the following lengths. ST is going to be 18, SR is going to be 82, and TR is going to be 80. And now we need to find the tangent of angle R and the tangent of angle S. So let's start with the tangent of angle R. The tangent of angle R is going to be equal to the leg that is opposite angle R and the leg that is adjacent to angle R. And so if we look at angle R right here, to go opposite, we're going to go straight across. So that's going to be ST, or 18. And if we look at angle R again, we need to go to the leg that is adjacent. So that's going to be this leg of 80 right there. So this is going to be 18 over 80. And if we take 18 over 80, that is equal to 9 over 40, or approximately 0.2250. Actually, it's straight equal to that. This one doesn't need to be rounded. All right, next we're going to go ahead and take a look at angle S. So we're going to take the tangent of angle S, and once again, it's going to be the opposite over the adjacent. And next lesson, I'll give you a little saying to order tangent, because we'll introduce sine and cosine. And so this is going to be the leg opposite to angle S over the leg that is adjacent to angle S. So we will, like I said, next time I'll give you a little strategy for remembering tangent, because we'll introduce sine and cosine as well. But if we look at angle S, the leg that's going to be opposite of angle S is going to be that length that is equal to 80. And the leg that's going to be adjacent to angle S is going to be the short one right here of 18. Remember, we're looking at the leg, not the hypotenuse. So if we take 80 over 18, which is equal to 40 over 9, that is going to be approximately equal to 4.4444. And that 4 is going to go on forever, but we wanted to round off at 4 decimal places. So we're going to go ahead and pause right there. Because my video did a little bit of a weird buffering thing right there, right in the middle of that example, I want to do another example. So let's go ahead and find the tangent of angle J and the tangent of angle K on this example. So we're going to draw another right triangle right here. This is going to be triangle JKL. L is going to be our right angle. And we're given the following measurements. JK is equal to 40, KL is equal to 24, and JL is equal to 32. And now if we go ahead and start by doing the tangent of angle J, that is going to be equal to the leg opposite angle J and the leg adjacent to angle J. And so if we identify angle J right down here, if we go opposite of J, that's going to be 24. And if we go adjacent to J, that's going to be 32. So 24 over 32 is going to be equal to 3 over 4, or 0.75. Brain, I can help out with factorization after I'm done with this tangent ratio lesson. And if we look at the tangent of angle K, oops, let me switch my colors here. This purple is nice. That's once again going to be the leg opposite angle J over the leg that is adjacent to angle A. Oops, K. I'm not J, K. And so if we go opposite, that's going to be 32. Adjacent is going to be 24, or 4 over 3, and that is equal to approximately 1.3333. You know, the 3 goes on forever. All right, now that we've done some examples where we have been given an angle and we found a ratio, we can now, if we're given an angle, find a leg measurement. So on this example, we want to find the value of x. So the tangent, oops, I should probably give you the triangle first before we get started on the example, right? So if we say this angle right here is 32 degrees, this leg over there is 11, and this leg down here is our unknown x. And then, of course, we've got our right angle right there. We know that this angle, the tangent of this angle of 32 degrees, is going to be equal to the leg that is opposite over the leg that is adjacent. So that's going to be 11 over x, right? Because that is opposite over adjacent. And so the tangent of, if we multiply both sides by x, right, to get x out of this denominator, we're going to get x multiplied by the tangent of 32 is equal to 11. And now we need to divide both sides by the tangent of 32. So x is equal to 11 over the tangent of 32 degrees. And now, if you go to any calculator, there's actually a tangent function. So if I swipe up real quick, go over here. Oh, where'd it go? There's my scientific calculator there. If we go into here, right, we want to take, where'd my example go? It just disappeared. There we go. We want to take 11 and divide that by the tangent of 32 degrees. And make sure you're in degrees up here. If you see a rad, switch that over to degrees. And that is going to be equal to approximately 17.6. So that is equal to approximately 17.6. All right, that calculator that I was using is the Desmos Scientific Calculator. If you have iOS, it's pretty nifty on iOS. If you don't have iOS, just go to Google, type in calculator, and the calculator that pops up will treat you just fine. Once again, though, make sure you're in degrees. All right, so if we want to do another example like that, where we find the value of x, we can do this triangle right here. There we go. X is going to be the short leg right here. Last time X was the long leg. This angle is going to be 61 degrees, and this leg right here is going to be equal to 22. So we're going to set that up by saying tangent of 61 degrees is equal to the opposite over the adjacent, so 22 over x. And so if we multiply the x across, we're going to get x multiplied by the tangent of 61 degrees is equal to 22. And we're going to divide both sides by the tangent of 61, so x is equal to 22 over the tangent of 61. And if we go ahead and type that in our calculator, I'm going to type that in on the Google calculator, just so I don't have to change my screen on my iPad. So that's going to be 22 divided by the tangent of 61, which is equal to approximately, so we'll put approximately 5.9. All right, so we just have a couple more examples that I want to do. First, I want to do find the tangent of 60 degrees. So this is going to be a tangent of any 60-degree angle. And so we know all 30, 60, 90 right triangles are similar. Right, we know every 30, 60, 90 right triangle is similar. Sophia, the app that I use for the calculator is the Desmos Scientific Calculator. So if we draw a right triangle here, and we're going to make this a 30, 60, 90 right triangle. Oops. There we go. We'll make that a triangle like that. This will be triangle, 30, 60, 90. It doesn't need a name. As long as this angle right here is 60 degrees, this angle is 30 degrees, and then our right angle is down here in the corner. So what we're going to do is we're going to make the shorter leg equal to 1. And so if we go identify our shorter leg, that's going to be equal to 1. And from theorem 9.5, we know that the longer leg is equal to the shorter leg multiplied by the square root of 3. And so if we take our short leg, which is equal to 1, multiply it by the square root of 3, our longer leg is equal to the square root of 3. So the tangent of a 60-degree angle, any 60-degree angle, is equal to the square root of 3 divided by 1, or the square root of 3. So the tangent of any 60-degree angle is the square root of 3, which is approximately equal to 1.7321. All right, so that's a nice fact to know that the tangent of 60 degrees, no matter what, is equal to 1.7321. All right, so finally, I got one last example here. I noticed my stream is buffering again. I really do apologize about that. We're going to go ahead and draw a tree. And so our tree is going to have some height down the center here, and we're going to call that H. And now let's say we're standing 45 feet away from the base of this tree at a right angle, of course. The tree's on the ground, we're on the ground, ground is flat. And we're looking up at this tree at a 59-degree angle. We want to find the height of the tree in this example. Jazz, if you're confused on some things, first try watching this replay without all the buffering. And if you're still having some troubles, please send me an email. So let's find the height of the tree. And so if we look at this angle, angle 59 degrees, the tangent of 59 degrees is going to be equal to the leg opposite over the leg that is adjacent. And so that's going to be equal to the leg opposite is H, and the leg adjacent is 45 feet. So the tangent of 59 degrees is equal to H over 45. And so now we need to isolate this H by taking 45 times the tangent of 59, which is equal to H. And if we go to our calculator, we can do 45 times the tangent of 59, and that is going to be equal to 74.89 feet. Or we can round that up to the height of the tree is approximately 75 feet. I am going to do another example like this because these are, some pretty not real world examples. I don't think anyone's gone out and stared up at a tree and used the angle of it unless it was in a math class. But, these are more applicable. So if we go ahead and make a flagpole here. So we're going to have our American flag and our flag is going to come down like that. It's going to, have a base down here. Whatever we fancy, right? Just a flagpole. And anyways, we're going to go ahead and come straight down to the ground at a right angle. And we're going to measure straight back like so. And our flagpole is going to have some height H. And let's go ahead. We're going to stand a little bit closer this time. So say we're standing about right there. So here's our beautiful face. And we're looking up at this flagpole at a 70-degree angle, and we're 40 feet away. So let's find the height of the flagpole. Well, we're going to take the tangent of 70 degrees, and that's going to be equal to the leg that is opposite over the leg that is adjacent. And so if we look at 70, let's go to the leg that is opposite, which is H, and the leg that is adjacent, which is 40. So the tangent of 70 is equal to h over 40. And so we need to multiply both sides by 40 to get 40 multiplied by the tangent of 70 is equal to h. And if we go to our calculator, type that in, 40 multiplied by the tangent of 70 is equal to 48.87. We'll approximate that as 48.9 feet.